Welcome all students from third year mechanical engineering. So in previous lectures we have seen the introductory part of this particular chapter, introduction to ferrous alloys. Coming to this total part of this syllabus, the brief classification of metals part we have completed. Inside that we have seen the two broad categories of ferrous and non-ferrous. At the same time we have seen the type of ferrous and type of non-ferrous type of alloys also. So carbon steel, alloy steel, and in non-ferrous various types of alloys from which are having melting point low to the refractory metals and their alloys. So that part we have completed in the classification of metals. Coming to the concept of alloying, now let us start with this lecture, the concept of alloying. So an alloy is a substance that has metallic properties and it is composed of two or more chemical elements of which at least one is a metal. So say alloy has broad definition that two or more chemical elements of which at least one is metal. So already in the first part, whenever we have seen the classification of metals, inside that we have in introduction we have seen the ferrous alloys. Inside that we have added the carbon or some alloy steels. Likewise, in case of cast iron also we have seen that 3 to 4.5% of carbon is present. In non-ferrous also we have seen some examples. In that we have seen that two or more chemical elements of which at least one is a metal. Then alloying elements are deliberately introduced into a metal to enhance its properties. The properties are of different kinds, maybe mechanical properties, wear resistant properties, maybe some another kind of properties, but especially whenever we are studying from mechanical engineering point of view, then we are focusing on mechanical properties. So alloying elements are purposefully introduced into a metal to enhance its mechanical properties. As a mechanical engineering point of view, we are focusing on mechanical properties. Maybe some other properties enhancement with thermal conductivity, electrical conductivity, wear resistance, but mechanical properties, so that is especially focused element. The metal present in the alloy is largest proportion is called as base metal. Suppose in case of ferrous alloys, if we consider if we are adding then if it is 0.25% or if it is up to 4.5%, then maximum amount 4.5%. The carbon we are adding inside this, but ferrous is in largest proportion. So ferrous we are considering as base metal in this case. And if carbon we are adding, maybe it is low carbon steel, medium carbon steel, high carbon steel, cast iron, etc. In all the cases, the percentage of the carbon as compared to ferrous is very less. And that's why we are considering the carbon as alloying elements and ferrous as a base metal. Okay, all other metals are elements added to the alloys are called as alloying elements. So carbon will be alloying element and ferrous is considered to be base metal. The metals are dissolved in each other while in a molten state they will not separate into layers when the solution is solidified. So the metals are dissolved in each other while in a molten state they will not separate into layers. Means one of the alloying element get dissolved into the another element. So then and then only we will consider this as an alloy. That the phase obtained after dissolving one of the alloying element in the base metal will be homogeneous and two inherent layers will not be identified. Like if we take the example of salt inside the water, the salt dissolves inside the water, then whatever the solution we are getting, that is homogeneous type of solution. We cannot identify different layer of salt and water inside this one. But if you take the example of different layer like structure, means in plywood, if there we observe the cross section of the plywood, we will be able to identify different layers. So whenever we are considering alloy, it does not have such a kind of different layers, but the metals are dissolved in each other, while in molten state they will not separate into layers when the solution is solidified. Practically all the metals used in aircraft are made of number of alloying elements. This is a very important part, that in aircraft we are using alloying element. Here we can take the example of pure aluminum, which is relatively soft. If we take the 99.999% pure aluminum, then it is soft and weak metal. But if we add the copper, manganese, magnesium, zinc, etc. in small amount also, then it becomes harder phase, it becomes stronger phase, it becomes that particular, whatever the exact properties we are expecting that particular phase by adding the different alloying elements. Okay. So it increases the strength. Then coming to purpose of alloy. So why we are going to make the alloy? So purpose of alloy. The most important application of alloying in aircraft industries by providing a high strength to weight ratio which could not be possible by pure metal. In naturally available metals, in pure metals, the strength to weight ratio is having certain range and there is certain limitation to improve this. But if we are making the alloy, then in that alloy it is possible to increase the high strength to weight ratio. Means in aerospace industries there is very important importance to the weight. For lighter weight it is very easy to fly. So fuel required in that case is less. So strength, we are not compromising in strength, but we are trying to reduce the weight, and that's why alloying is important in order to get high strength to weight ratio. A homogeneous mixture of solid solution of two or more metals established in such a way that atoms of one metal replace or occupy interstitial position between the atoms of other metals. Means if we find the structure, then the alloying elements occupies intermediate positions in the base metals. Okay. Now alloying of the metals can be done to prevent the rust. Means we'll take the example of chromium. If chromium and nickel is added to the iron, then it forms the stainless steel. And stainless steel have the property of corrosion resistance. So chromium can form an oxide layer that can prevent iron to oxidize. So added chromium has advantage that it forms the layer or oxide layer which prevents iron to oxidize. So alloying is also suitable to make fork, spoon and other such equipment. To make the harder phases. So first purpose was to prevent the rust and second purpose is to make it harder. For example, carbon is added to the iron and then it forms the steel that we have seen, the low, medium and high carbon steel. But addition of carbon will increase the hardness of the steel. So steel is very hard as well as brittle material. As compared to pure ferrous material, if we add the carbon, then steel is very hard and brittle material. It is suitable to make the bridge, car body, pipes, etc. And that is possible due to addition of carbon, so alloying. Then, so one more example is given here. Aluminum is very light but very malleable material. When copper or magnesium is added to it, it forms the duraluminium. So duraluminium is very hard, which time to corrosion and light in weight, it is suitable to make a aeroplane body. And the third purpose, along with other two purposes, is to improve the appearance. A normal metal usually gets dull when exposed to the air, water and UV light for long period of time. To create an attractive surface and look metals such as nickel and chromium. So when it is nickel and chromium is added or copper is added to form alloy named cypronickel, such alloys when used to make coins attractive and shining. So see, the example is given here. We can observe that by alloying we can change the appearance, we can change the aesthetic look of that material. So one example is given here, that nickel when added to copper to form an alloy named cypronickel, then such an alloy used to make coin which is attractive and shining. So the purpose of alloying, we can see that to prevent the rust, to make the particular alloy or particular addition as a harder phase, then to improve the appearance. So we can say that these are the purpose of alloying. Okay. So this is the part related with the this concept of alloying. Okay. So we can see the purpose, what is meant by alloy, to whom we say as alloy. Then secondly, what is the base metal, then what is alloying element, then what is the example of alloy, which are the base metals, which are the alloying metals, what is the purpose of alloying, and with this particular bit is completed here. So thank you very much.